So this will be class 7 of our tutorial series on data science and machine learning, and today we are going to be talking about logistic regression. Actually, I say that this class is going to be practical, but in case of logistic regression, I would like to just show you a little bit of the theory behind logistic regression. Now, if I go to my whiteboard, I have this logistic regression. So basically, when we have to analyze data, we have X and we have Y, and you are given values for X and Y, let's say 2, 3, 4, 3, 4, 1, 2, and so on. So you want to find out the relationship between these two variables, and what you do normally, or what the system does, is what we do when we plot a graph. We have Y, we have X, and you plot this point in the graph, okay? After you plot the point, you want to fit a line to this point. And now, from what we learned from high school, a line have an equation, and that equation is given by y is equal to mx plus c. Okay, so in other words, y is equal to f of x, which is equal to, now what is m and what is c? So m is this is slope of this graph, and this is the intercept. So this is where it intersects the y-axis, and the slope is also calculated using the formula for calculating slope. So I'm not going to be talking about this, but in data analysis, in data science, we say that the equation for a line is given by y is equal to f of x, which is equal to beta 0 plus beta 1x. Okay, so this is the same thing. It's a fancy way of writing this equation we learned from high school. Y is equal to mx plus c is equal to beta 0 plus beta 1x. So this is equation for this line, and this is also very clear. So how to calculate the beta 0 and beta 1, which is actually beta 0 is the slope, is the intercept, and beta 1 is the slope. Now, if you do this, you have a line that goes this way. However, when it comes to logistic regression, the y values are only two. There are only two classes in the y value. So you have either 0, 1, 1, just like this. So when you plot something like this, you have something like y is 1 and y is 0. So you have the points in this graph for a logistic regression data set is going to just be something like this. Let me just write it. It's going to be clustering somewhere here. So these are your points, how this graph is going to, the points are going to look like. So you can't actually fit a line through a data set like this. To illustrate this, let's now go to the whiteboard, but yeah, let's go back to our Python code, and let me just show you how a logistic regression data set looks like. So if I open this default data frame, which I have on my file system, is a default.csv. I imported it from RStudio, but if you find out in the description box of this video, you can find a link to this data, and it says default df. Now let's just run this, run. Okay, so we have default is no and yes. Okay, so it's no and yes because I already know that the default column contains yes and no. So basically, these are customer records. Given the balance on the account of the customer, I want to calculate or check if the customer is going to default. We want to predict if the customer is going to default in his credit card debt. Okay, so that's what we want to predict here. So in this case, we only have yes and no. He will default, he will not default. So when we have values like yes and no, which we actually map to 0 and 1, we have to solve this problem using logistic regression. And if you are using logistic regression, this equation of a line, this famous equation we normally use to solve problems, will fail. It's not going to work. Therefore, what we need is a way to map the output into a 0 or a 1. So what we are saying in effect is we want this part of the equation to result in only two different distinct value, either a 0 or a 1. So how do we solve this problem? The way to solve this problem, there are two ways. First, we need a function that's going to return value between 0 and 1. And secondly, we need a threshold to round off the output. So to solve the first issue, we need to model the outputs as probabilities. So instead of calculating something that's going to result in 0 and 1, we simply calculate the probability of a 0 given the balance. That's called the posterior probability. Now, I don't want to confuse you with all these terms, but this is what I wrote here. So we calculate probability that there will be a 1 given the balance. So I'm going to write in my whiteboard. So what we are calculating is this probability PR of the balance, that the default column, which is the column we want to calculate, will be yes, given the balance in the account. And this is written as P balance. Okay, so this now what we are going to use, the probabilities instead of the actual values, is what we are going to be using for logistic regression. So this is a theoretical model. And if we do that, if we go back here, the graph we are going to that's going to result now is going to be something like this. It's going to come to something like this. So this is the kind of graph that we're going to have. So we are not going to have a straight line graph, but we are going to have a sigmoid graph that looks like this. All right, let's dive right into the practical at this point. So I'm going to go back to my whiteboard. So let me to the Python, to Jupyter Notebook. And now we are going to be importing everything we need. So this, actually, I'm going to be copying and pasting at this time. So all these modules I'm going to copy and paste. I'm going to explain to you what they are going to be used for. So we have datasets import from sklearn.dataset import make classification. This is a dataset. This is a module that gives us a dataset. We can use to synthesize a dataset. Matplotlib is for plotting. Sklearn.linear model is the model that we can use to perform logistic regression. This is a model for splitting our dataset. Sklearn model selection, train, test, split, for splitting our data into training and test dataset. And this confusion matrix coming from sklearn.metrics is for viewing the confusion matrix. I explained it in the previous class. And pandas is for creating data frames. So as I used to mention, I'm going to type out this code. So let's create our data set. Let's synthesize this data set, but permit me to kind of increase this font a little bit. All right, so I'm going to synthesize my data set. It's going to be x and y is two variables is equal to make underscore classification. And now make classification function takes a number of parameters. So first we need n samples, let's say 100, and we also need number of features. Number of features in this case is going to be just 1. It's equal to 1. The number of classes is 2, which is 0 and 1, right? So it's 2. And at this point, I'm just going to copy everything and paste, because this actually they are actually optional at this point. So I'm going to just paste them so that we don't waste all the time. So now we have this. So I'm going to run, and now we have an error. Make classification is not defined. So we have a typo here. It's going to be double S and not triple S. So we have our X and Y data that's been created for us. So we now want to plot this data to see how it looks like, and let's understand that this data cannot be solved using normal linear or simple linear regression. So I'm going to say plt.scatter, and it's going to be x, y, c is equal to y, and color map, but I think this should be yellow. Color is equal to yellow, and color map, of course, I think this C map is going to override this. I can use rainbow. I can also use something else like prism, and I'm going to say plt.show. Now I can now do other things like adding a grid and adding a title, But now you can see the data set. This is exactly how the data set looks like, and we need to perform logistic regression on this kind of data set. All right, so how do we now perform logistic regression? First, we want to split our data set into train, test, split. So I have the code here. I'm going to also type it out, like I used to recommend you type out your code. In that way, it makes it easier for you. So I have x train, x test, y train, and y test is equal to train test split, and give it your data set, which is x and y. Random state, I don't have an idea of this, but I've been using it for a long time. The random state is equal to 1. I'm gonna hit the run button. Okay, so we split our data set into train and test data set. We now want to create a logistic regression object. So I'm going to say log reg is equal to logistic regression, and I'm going to fit this logistic regression model into our data set. So I'm going to say log reg the speed, and I'm going to give it x train, x train, and y train. I'm going to run. Okay, so we have the logistic regression object created. Now we can check the metrics. We can check the accuracy, or we can actually check the coefficients and the intercept. That's beta 0 plus beta 1x. So I'm going to simply say print. I can actually just display log reg dot coef. So this is the coefficient of the. Okay, so I'm simply going to print it. So I don't want to see this array of the thing here. So these are coefficients. I think I'm not missing out anything. Yeah. So these are coefficients 2.7574. Coefficient you already know what it means. So that is beta 0, which is, sorry, give me 1 second. Coefficient and intercept. So get back here. So when we say coefficient, we mean the m here, which is beta 1. All right. So, and the intercept is, I'm going to print out the intercept as well. Print log reg dot intercept. I'm going to hit this key. All right. So these are intercept. Okay. So this is basically the formula for logistic regression. So you can actually literally fit in this formula into this place and get your y values. You can also check the confusion matrix. So I'm going to say confusion matrix. Already you know what this means, confusion matrix. So it helps us to see how well our model performed. So confusion matrix, I'm giving it, but we need to make prediction first. So I'm going to predict y pred is equal to log reg dot predict. I'm giving it the x text. So x text, so it makes prediction. So I'm going to display the confusion matrix now. So I'm going to give it the y test and the predicted value. So it's going to be y pred. Okay. So our model did pretty well. So here we have the top left. So this top left here is a true positive. So true positive testing, which is great. Lower right, which is this time, is a true negative. So actually we did so well in doing good prediction, but lower right, which is this 2, lower right is the true negative. Sorry, so give me 1 second. Yeah, true negative here. So lower left is what I'm talking about. So this is a false negative. There's a false negative, and here you have the false positive. So we only failed 2. This model only failed 2 of them. Now we are talking about logistic regression. Now we want to check the actual probability that a data point set belongs to a class, and to do that, what are we saying? We are saying that for each of the predicted values, we want to check display the probability that it belongs to either a yes or a no. So I'm going to display this data, and I'm going to explain it to you. So I'm going to say log reg dot predict probability proba, and we have x test. I'm going to hit the escape. All right, so what is happening here? So this is actually the values that we are going to be using to actually plot, to create the logistic plot, or the sigmoid plot, or the logistic curve. So what here means is that for x test, we have probability that it belongs to a 0 is this one, a 0.23, and probability that it belongs to a 1 is 0.76. Meaning that in this case, we assign it to 1 because it have a higher probability. So this is actually predicted values. Now this is the probability of the predicted value for each of the classes, which is either a 0 or a 1. In this case, we are talking about a yes or a no. Now when it comes to the sigmoid plot, we now need to create a data frame, and then we need to do a plot. Now I really don't have time to explain this, but I hope I can. But let me just copy and paste it, then I'm going to do a bit of explanation to you, and then I allow you to play around and also read up the materials I put in the description box of this video, so you understand a little bit. For now, you don't have to worry so much about understanding every detail about this code. However, the sigmoid function is going to, the xpit function, this xpit function is actually going to take the normal equation and then convert it into a sigmoid equation. What is a sigmoid equation? Permit me to just go back to my whiteboard one more time. Just finally, we have y is equal to beta 0 plus beta 1 x. Now the equivalent sigmoid function or logistic function, if I can remember, should be y is equal to e to the power of beta 0 plus beta 1 x all over 1 plus e to the power of beta 0 plus beta 1 x. So this equation we use for logistic regression, and this is the equation we use for simple linear or linear regression. And so to convert this equation to this, we use the xpit function, and that is what you see. That's what you see right here. This xpit function, we have x times coefficient plus coefficients. We have beta 0 plus beta 1x plus beta 0, which is about the same. So we have x times beta 1, which is the coefficient, plus beta 0, which is the intercept. We are using the revel function so that we can convert the column vector to an array. So at this point, we do a scatter plot, and that is what we have here. I'm going to simply run it, and it says plt.show. Oh yeah, so this is plt.show. So we can just close up these braces here. And it tells us x test is not defined. Oh yeah, so we have x test should be actually x test, and this should be y test. Okay, so let's run it. Yeah. All right, so these are sigmoid function, and take some time to write this code out yourself. It becomes clearer as you go. But for now, I recommend, if you don't understand this logistic regression perfectly well, don't worry yourself. With time, we are going to come back to it when we are going to be doing actual regression analysis in this class. So this is basically it about logistic regression. The summary of what we are saying here is that for us to perform logistic regression, we need to use probabilities that the values belong to classes. So we use probabilities instead of using the actual value, and we're actually going to be using the logistic function instead of the normal regression function, right? So this is basically what logistic regression is all about. So I'm going to be stopping here. I'd like to thank you for viewing. Please remember to subscribe to my channel. If you have challenges, please leave it to me as a comment. And again, the best way to learn is type it out yourself. Even if you don't understand it clearly, please type it out yourself in your Jupyter notebook. The more you do it, the clearer it becomes. So let's move on to the next part. I can't remember the next topic, honestly, but also remember, I'm Kind the Tech Pro, and I'm always there for you.